In this session, we're going to talk about sphingolipid synthesis. Now, sphingolipids they carry the same theme as glycerophospholipids with a 3-carbon backbone. However, the synthesis of this is a bit more complex. So what I'd like to do is restrict our discussion to sphingomyelin, which is most predominantly expressed and found in nerve cells. So these specialized lipids assist in nerve cell function, and that's why they're important to discuss. So let's start out by drawing one of the substrates for sphingolipid synthesis in a 3-carbon backbone structure. In this way, we will have our side chain of serine, we will have our primary amine of the serine molecule, this being the alpha carbon, and we will have the carboxylic acid. So this is the amino acid serine, and this is going to be the 3-carbon backbone for sphingolipid synthesis, and this is going to replicate basically the same principle as the glycerol backbone for triglycerides and phospholipids. Now, the first step for sphingolipid synthesis is a decarboxylation step. So essentially, this portion of the serine amino acid will be removed, and in its place will be a fatty acid structure. So let's draw our 3-carbon backbone theme. And now this will essentially be our hydrocarbon fatty acid tail. So essentially what we've done is we've replaced the carboxylic acid with the fatty acid group, including the carbonyl. Now the next step of this reaction is a redox reaction, and we are going to be using NADPH, converting to NADP, and what we are reducing is this carbonyl structure. And of course, reducing the carbonyl, we're going to convert it to an alcohol. Now, the next step of this reaction is going to be adding a fatty acid onto the nitrogen. Once we have the fatty acid on the nitrogen, we now have 2 fatty acid chains, and we have a free hydroxyl group for our 3rd addition. And our 3rd addition, in the case of sphingomyelin, is going to be the addition of CDP choline. Remember, choline is ethanolamine with 3 methyl groups on the nitrogen. And so what we will end up forming, our final product, is sphingomyelin. Now, if you look carefully at the sphingolipid synthesis pathway, you'll also find that there is a double bond in this fatty acid. This fatty acid structure here, originally being added in the first step, of course, is a fatty acyl CoA, and this is always a palmitate CoA structure. So this is our familiar C16 fatty acid. This particular fatty acid also has a desaturase step, which is going to introduce a double bond to unsaturate the palmitate. And then that will give us our final structure of sphingomyelin.